So the Amy project is about really showing the potential of AI and autonomous systems to be used for industries both within our region but also for the whole eastern and middle Sweden. Each of our cases are shown in a demonstrator, and here we collect all our demonstrators in a robot lab where it is available both for testing and development but also for showing examples of what is possible with the current technology today. So one area that we look at is how humans and robots can collaborate together to perform a common task. One case that we worked on, AutoHic, involves a company in Karlskoga, MH Engineering, and together with our researchers have developed new methods to enable the teleoperation of heavy industrial robots.
For the operator, doing high-velocity metal coating is a problematic task because of several factors. It's a noisy environment, it's an environment with a lot of dust, it's an environment with a lot of fine particles that shouldn't be breathed in. What we see here is the operator controlling robotic arm using the so-called interaction proxy. We're using this virtual ball, which is used to track robot position and orientation.
Along the lines of human-robot collaboration, we also have another case called AutoDive. Again, using a lot of the same technologies, we move from a heavy industrial environment into an underwater scenario, where we again see how teleoperation can be used in order to control underwater vehicles.
We want to develop some more powerful machine learning approaches to drive the multiple robots. And we want to create a computer vision technology that is to give the multiple robots an eye to let them identify the whole world, the environment and the tasks.
Vad vi hoppas att få ut av det här projektet är att vi ska starta ett djupare samarbete mellan Örebro Universitet och oss. För det finns väldigt mycket intressant teknik som man utvecklar här på universitetet som har stark koppling till våra produkter och den framtidsagendan som vi har egentligen inom olika områden inom robotik.
So another common theme that we have is looking at when two robots or more need to collaborate together to solve a task. And one case, AutoDPP, looked at the scenario where you have drilling robots for mining industry collaborating with each other in order to solve the task.
The robot's arm is a very complex structure. It has a lot of joints. We actually have to control each of the joints to move. So the structure is very complicated. And now we would like to coordinate multiple robots. So the calculation would be even more complex.
Vi har ett första steg mot den här funktionen redan. Men den räcker inte riktigt till. Men med hjälp av det tekniksprång som jag hoppas vi kommer göra här så kommer vi att förbättra vår produktivitet en hel del.
Along the theme of collaborating robots, there was also a case called CoRob. And in CoRob, here we look at how different types of robots, whether it's a ground vehicle or a drone, can communicate with each other, share information, and again, solve a common task.
Här på Örebro Universitet så har vi kombinerat två olika tekniker, maskininlärning och kunskapsresonemang. I maskininlärning så klassificerar vi datat som vi ser och sedan resonerar vi om överresultaten.
Not all our cases involve robots. Some of our cases also involve state-of-the-art technology and looking in particular about how humans can benefit of new forms of technology like VR. In a case with Kopparbergs Bryggeri, we took a look at how a brewery that has a lot of seasonal workers can make use of VR in order to rapidly train workers and get them going without necessarily putting expensive equipment at risk or suffering from too much downtime in getting the workers trained.
Operatören tar på sig en HoloLens som är en sorts glasögon-headset där man kan projicera digitala objekt i den verkliga världen. I det här applikationen som vi har byggt, då följer man liksom olika steg i hur man bygger om en maskin. Steg för steg, ett steg åt gången. Var någonstans på maskinen man ska befinna sig får man hjälp med att gå dit och sen så instruktioner hur man ska liksom anpassa maskinen i det steget.
Really, to look at the state of the art of AI and autonomous systems, a fundamental ingredient is handling sensor data. And we are dealing with more and more sensor data everywhere around us. And this is very much true in one of the cases we examined called digital twins, where we look at a digital twin, but we take it one step further by adding a layer of AI that's able to look at how you can combine a digital twin with real-time sensor information.
Den digitala tvillingen kommer kunna användas av besökare för att hitta till exempel grupprum, toaletter, bokhyllor kopplat till en viss bok och så vidare. Förvaltare kommer kunna använda den digitala tvillingen för att hitta driftutrymmen, kommer söka efter felanmälningar till exempel. Om det är en lampa som går sönder så kommer man kunna hitta den felande lampan direkt i modellen.
One thing is clear is that we are going to be facing a number of very large societal challenges. And we want to make sure that AI and autonomous systems are being used to help us confront those challenges. We pushed the forefront by exploring new types of applications, particularly those that involved sustainability. We have two such cases in this theme. The first case is a case that we call AgTech, where we're using mobile robots to help in agricultural settings in order to transport items from one location to the next.
The harvest robots are built to pick up and carry small to medium-sized objects. By giving them the addition of ROS, it makes it a much simpler task to add features to these robots, allowing them a more diverse application, which will be able to help not just in the agricultural industry, but anywhere that someone can think of a use for a system like this.
This is an important project for us at Harvest Automation because we believe the open interface will dramatically increase the ease and pace with which new applications can be assessed and developed on our platform.
The other example is looking at how we can use both sensing technology and automation to facilitate indoor growing. Here we created a test bed called LUMAS, which we could play around with different parameters like soil quality, lighting quality, and really investigate how we can bring indoor growing in a sustainable manner to the market.
Med hjälp av sensorer, en robotarm och en trådlös uppkoppling så övervakas odlingsprocessen på distans och den kan skötas med hjälp av en dator. Visionen är att med hjälp av artificiell intelligens och sensornätverk kunna få en optimal tillväxt och perfekta förutsättningar för odling.
Den första målgruppen vi ser är restauranger och matkreatörer som vill profilera sig med färska, unika råvaror som inte finns i handeln och som är lokalt och hållbart producerade. Men vi tror även att hemmaodlare är intresserade av den här produkten och skolor som kan använda det som ett pedagogiskt redskap.
So now you've seen a short overview of some of our cases, but it's important to mention that there have been several cases that haven't necessarily led to a demonstrator. Now, while one may consider that this is a failure, we also have to remember that through failures, that's how we learn lessons. We've had a number of experiences within this Amy project where we've seen where the new challenges are. We need to be better at working with our small and medium-sized enterprises. We need to be better at really demonstrating the true value of AI and autonomous systems for businesses. And we need to be better at really using this technology to help us confront our societal challenges going forward.